Okie dokie, that brings us to connective tissue. They are very diverse, but have a common embryonic origin. Generally speaking, connective tissue is composed of cells and intercellular substances. Inter means between. So these substances are outside of the cell, in between the cells. We call them the extracellular matrix. And when we analyze that a little bit more, those are made out of fibers and ground substance. The ground substance can be liquid, watery, serum in the blood, or it can be the hard material in bone that doesn't let anything move. That's the stuff that the cells secrete. Talking about fibers, we have three main types. We have collagen fibers, and that is non-distensible. It will not give when you pull on either end of them. Ligaments are like that, and tendons. Ligaments are attachments from bone to bone. They hold bones together. They're kind of like rubber bands. And tendons are connections between muscle and bone. Elastic fibers are distensible to about 1.5 times their own length. A good example is the cartilage in our ears. See, the ear you can twist and bend until your grandmother tells you not to do that, because it will stay that way, but the thing is, it will not stay that way. It will go right back. So you can extend it like a rubber band, it will roll right back to its original shape. That's pretty neat. If you look at the slides, you see wavy lines in the middle slide there. Those are elastic fibers. And then finally we have reticular fibers, and those are flexible and make good sieve structures. Lymph nodes are good examples. What they do is they have immune cells in them that help filter the body fluid. White blood cells sit in that sieve structure that is made by reticular fibers and just hang on to them and wait till they get some bad stuff coming through that they can shoot down and kill. I know, kind of gruesome, huh? But helpful. Let's give us some connective tissue examples since it is so diverse. Loose areolar connective tissue forms sheaths of fabric surrounding organs and connecting them. It stores water and allows other tissues room to shift around. If you ever skin a chicken, you see the shiny stuff? That's loose areolar connective tissue. Our bodies come in layers, and in between those layers we have those tissues. So the layers then can freely move past one another. Adipose tissue is energy storage fat and also structural support fat. So I took these two pictures up here. On one side you see an obese person, on the other side just a normal person, and you can see unfortunately how the fat tries to infiltrate everything, and we get much more fat around organs, and that can be dangerous and not good for our health. So we do want to work against that. Hip fat is not as dramatic in that respect. It seems to be better for us, because we don't want to just all make skinny people. That's not the point. That's not healthy either. So be very aware of that. Then we have dense fibrous connective tissue. That has a lot of collagen fibers in them. So we can use that tissue wherever we need strength. We can have an outside shell around an organ is composed of that, or also the ligaments are composed of that, and of course our tendons that connect and anchor muscle into a bone. Blood is connective tissue. Reticular connective tissue is the one that has a lot of reticular fibers in them. So we use that again where we need sieve-like structures, like in our lymph nodes. And then lastly, we're looking at supporting connective tissue, and those are our bones and our cartilage, which those are the ones we'll discuss next. So we're going to go through cartilage, and then we're going to go into bone. Cartilage we found in the skeleton and in the airways, where we need stable but flexible structures. For example, the coverings at the ends of bones will make movement easier and less painful. Tracheal rings around the windpipe. There's rings in the windpipe. If you actually touch your throat, you can feel them. It doesn't all just collapse. Those help keep the airway open, because air is not strong enough to push it open if we would have to do that. We can do that with the food pipe. And you can see that in the bottom right slide. You have the trachea is open, and the esophagus, which is the food pipe, is closed. The food will push it open. Cartilage has a high resistance to pressure, and it is capable of viscoelastic deformation. Oh boy, what in the world does viscoelastic mean? Well, it's kind of the material you have in earplugs. You squeeze them together, they hold that squeeze a little bit, so they're moldable. But when you let them go, they fill back up and they come back to their original shape. That's what viscoelastic means. We have cells in that tissue, and those cells live in this material that's quite sturdy and solid, so they need little spaces to live in, and we call those spaces lacunae. Cartilage tissue is avascular tissue. So that means there's no blood supply. What does that mean? That means when we have a cut in it, it's really hard to heal because blood heals, or bringing blood to the area will heal the tissue. The other thing it means is blood also brings us nutrients. So how in the world are we going to get nutrients and food into this cartilage and get rid of the waste products? Well, cartilage is fed by diffusion or directly by synovial fluid when we move. So what we need to do is we need to squeeze the cartilage like a sponge, and the water will flow out of it. Well, guess what? What happens when we let go of the sponge, we can suck up new water. Cartilage works in the same way. We squeeze it a little bit, squeeze the liquid out of it, and then let it go, and it sucks up new nutrients and new material. The avascularity diminishes the regenerative capacity of this tissue greatly. And that will bring us to the types of cartilage. Well, we have 3 types. We have hyaline cartilage, and that's kind of cool looking. It looks like milky blue, sort of has an appearance like you're looking through a ground glass, like the bottom of a bottle or something. Where we find that one, it covers joint surfaces and is also part of the ribs, the part in the front. And also the nose in the front, that's also hyaline cartilage, as well as the larynx, the rings of the trachea, and the large bronchi. What the world are those? Well, the larynx is your voice box. The rings of the trachea are the ones around the windpipe, so they keep that open. And the bronchi is the same thing. We need to have the bronchi open. That's the windpipe as it goes into the lungs once it splits. Then next we have elastic cartilage. And that one is basically hyaline cartilage with a lot of elastic fibers in them. It looks sort of yellowish in appearance. We have that and find that in the ear, in the auricle. That's the outer part of the ear. Also, the epiglottis, which is part of the larynx, has it. What that is that's the flap that flaps down and covers the windpipe when food goes down the food pipe. Because we don't want food to accidentally go down the windpipe. Guess what? We choke when we do that. When we choke, the epiglottis has not done its job properly, or maybe we try to talk when we eat. Then also we find that elastic cartilage a little bit in the outside part of the ear canal, the external auditory meatus. Lastly here, let's do fibrocartilage. Fibrocartilage contains more collagen fiber than hyaline cartilage does, making it tougher material. We find that mostly in the intervertebral disc, between the bones in the back of the spine, and also in the front by the pubic symphysis. You remember pubic, that area? And then we find it in the menisci of our knees. The meniscus of the knees are they're like plastic pieces that help the knee guide through proper range of motion. I know, huh? A lot of stuff. It's good. That way you're a complicated person and not just some simple slob on the floor.